Hello friend, once again welcome on board, and today I am going to discuss about ATA chapter 21 Avionics ventilation system of Airbus 320 family. So guys, sit back, relax and enjoy this video till in and don't forget to like and subscribe for getting more video on Airbus 320 system. So guys, this is my YouTube channel, please like and subscribe. And Avionics ventilation system. Avionics ventilation system operate in different configuration. These configuration are depend on ambient temperature, whether the aircraft is on ground or in flight. So just keep in mind there is a different configuration. We'll discuss in next slide. Avionics ventilation system is fully automatic. It cools the electronic component in avionics compartment, flight deck, including instruments, circuit breakers. So whatever equipment is there in the cockpit, they are going to generate lot of heat while operation. So to maintain the temperature of all the computer within the limit, we are using avionics equipment ventilation system. So it uses two electrical fan to force the circulation of cool air throughout the system. So if you talk about where the computer is installed, there is a lot of rack. So rack, if you'll see, I'll take example of rack equipment installed in the rack is cooled with the air blown into the base of the rack through a sealed inlet. So there air will blow onto the base of the rack through the sealed inlet. I'll show you in the video in next slide. This air then flow through the equipment to the top of the rack and remove through the unsealed outlet. After cooling, and a hot air gas will remove from the other port. Other equipment installed on the rack is cooled with the air blown into the base, then out at the top. So we'll just go through the next slide. Display unit located in the pilot panel are cooled with air blown through the sealed inlet outlet. Same procedure for the display unit. Same procedure for pedestal instrument, also cooled air blown through the instrument on the upper panel around the instrument of lower panel. Then air goes into the avionics compartment through the vent in the cockpit floor. Overhead circuit breaker system control panel are cooled with cockpit air. This air is drawn around the back of the panel into the avionics ventilation system. So overall scenario of this is cooling mechanism is almost same for every computer because there is a 90 view, 80 view. Most of the computer is available in this compartment as well as in the cockpit. So procedure is same, ventilation system is same. So if you see, I'll play this video, you will understand. So this is your ATVU compartment. You can see there is a lot of orange duct connecting with the filter, and because before air will go to the avionics compartment, air must be filtered to prevent the dust at all. And you can see all the this is your rack where computer will install. You'll see there is a hole, and top of the rack also there is a hole. So both place air will come, and through the computer you can see there is a mesh. Air will go into the computer and it will blow out all the hot gases in the compartment. And you can see here is the orange duct which is connecting with the rack main chamber, and from there only it is distributing to the all the rack base metal and from the top also. So this is a general information. And if you go toward the forward area, this is your exit port. So you should see this is a schematic diagram. Very good to know about this diagram. We'll go quickly about this, so it will be make you better understanding. Just for example, this is your aircraft surface skin air wall. Okay, I'll not mention any fin number. I'll just take an example. Air is going through the skin air wall. There will be the check valve which is visual from the ground. Then it will go to the demister filter to prevent all the dust or moisture before going to the computer. Then there is a blower fan. This will create a suction of air. It will throw the air. Again it will go to the check valve. Then it will distribute it in two places. First will go 80 view compartment avionics rack, and this will cool all the avionics computer, and air will blown out and it will go to the extractor fan, and further it will go through the outlet wall. So the sum of the air depend on the configuration. We'll discuss in the next. Some of the air will go this underfloor area, some of the air will go for a skin heat exchanger control, and on ground it will go exit through this way. So a skin air isolation valve is there, we'll discuss in the next slide. So again, if you are going further, demister filter, blower fan, then check valve, again air is distributed to skin heat exchanger, then it will distributed to window computer, forward access door, pedestal panel area, then pilot panel area, central pedestal panel area. You can see, just check the arrow mark, it will almost it will cool all the avionics equipment, TRU, whatever computer is there, and 90 view compartment, TR computers, this all will cool, and again it will exit through this skin air valve. So here also air will, after cooling, it will exit and it will go and it will exit through the skin air valve. So this is just general idea about lot of pressure sensor is there, detection. This will discuss one by one in air conditioning chapter. So this is just general idea about how the avionics equipment is getting cool. Here also you can see overhead panel, it will take air from surrounding area and this will cool all the circuit breaker, then again it will go to the exit ports. So this is your avionics equipment. This is just for your knowledge. I got on my type rating course what are the component is there, you can find out in Airbus 320 family location. This is your heat exchanger, this is your smoke detector, and I'll not go through all. Here you'll find out a demister filter and air inlet check valve. Okay, so this you can go, just for your knowledge, you can go through this video. So whatever component is there, we'll just know what is the purpose of all the component. Skin air inlet and outlet valve. These valves are allow the air from outside the aircraft and evacuate hot air from the avionics equipment. This both valve is visual from outside. Left side is skin air inlet valve, our right side is outlet valve. Skin exchange inlet and outlet bypass valve. This valve enable the air to circulate between the avionics bay and space under the cargo compartment air. So that's why they have used outlet bypass valve. Another is air conditioning inlet valve. This valve open to enable the air conditioning circuit to supply fresh air to the avionics bay. So once you are using air conditioning, in-flight air conditioning system will provide this cooling system. So this is for that only. Skin exchange isolation valve. This valve connect or isolate the skin heat exchangers. So there is a valve I told you in previous slide. So that valve can be isolated from the skin heat exchanger. Avionics equipment ventilation computer. AEVC control the operation of all fan valve in avionics ventilation system. AEVC change the system configuration depending on the aircraft is on ground or in flight, and aircraft skin temperature. Already regarding skin temperature, I have uploaded video on my YouTube channel. You can search on my channel. So now this is the main part of avionics equipment ventilation system. There is a three configuration: open circuit configuration and closed circuit, then intermediate, or you can say partial circuit configuration. So on ground, open circuit configuration operate when the skin temperature is above the ground threshold. Open circuit configuration, ambient air draw through the skin air inlet valve by blower fan and is blown into the system. Air after cooling the avionics equipment is drawn by the extraction fan directly overboard. So open circuit configuration, what I will tell you in the diagram in next. Just we will go through the theory. Open circuit configuration allow the avionics equipment to be cooled with ambient air under the certain condition. So on ground, skin temperature is above 12 degree temperature increasing or below 9 plus 9 degree temperature decreasing. Skin air inlet outlet valve are fully open condition. That's why it's called open circuit configuration. In some case, the opening of skin air valve can be delayed even if the skin temperature is above the ground threshold. There can be delay depending on the skin temperature. This is to avoid the condensation phenomena when the temperature inside the avionics compartment is too cold. So if there is too cool temperature, that there will be the delay of opening closing of the valve. So in open circuit configuration, if you see, this is your skin air inlet on the left side of the aircraft, this is your skin air outlet on the right side of the aircraft. You will see this valve is open, air is going inside, blower fan is rotating and air is sucking, and it is going to the avionics equipment ventilation, and then extractor fan will rotate and it will blown out through the skin air outlets wall. In open circuit configuration, just you can see a straight line you forward and it will go to the skin air outlet wall. Here there is no use of skin exchanger isolation wall or bypass wall or skin heat exchanger, whatever is there. So this is open circuit configuration. If you go in the closed circuit, open circuit configuration, now you can see there, if you go on the ECOM cabin pressure page, this is your inlet and outlet wall. You'll see this both valve is open condition. On ground and outflow valve is already, it will open after touchdown. So just the best example, inlet outlet valve both are open, means aircraft is on ground. If it is in the air, it will back to the air turn back. So in flight operation, next is a closed circuit configuration. The extracted avionics equipment air goes through a skin exchanger isolation wall into the skin heat exchanger to be cooled. Then this air blown into the avionics equipment again. Skin exchanger inlet bypass valve is controlled by AEVC computer in accordance to the system configuration to discharge air under the forward cargo compartment. Skin exchanger outlet bypass valve open in order to decrease the noise level into the avionics bay. So this is just to reduce the noise level. This is your temperature configuration, plus 35 degree temperature increasing, plus 35 degree 31 degree temperature decreasing in flight configuration. We'll not go about the temperature, we'll just try to know the concept. So closed circuit configuration, you see this valve is closed now because you are in flight, and this valve, inlet valve, you can see physically from outside it is closed because you are in air, you cannot see from in air, but on ECOM display this inlet outlet valve is closed. Now what happened? Blower fan is rotating and it will take air surrounding area, and avionics equipment will cool. Then it will go through the extraction fan, skin exchanger isolation wall, and some air will go to the bypass valve area under the cargo floor area. Then skin heat exchanger will reduce the temperature. That's why there is a skin temperature sensor available on the right side of the fuselage, which already I have discussed in my YouTube channel. Please go through that. So this skin heat exchanger means what? Outside temperature is already very less. So what happened? You are giving, just there is a chamber, you can say there is a chamber, you are throwing hot air, and skin to skin heat will transfer, and that air will be heat will be reduced, and then it will go to the outlet bypass valve avionics equipment, and it will cool and recirculate to this avionics ventilation system. So air is going through the blower, avionics fan, this, then heat exchanger, then it will suck through the avionics air, additional air, bypass valve, and again it will re-rotate. So this is your closed circuit configuration. Now there is the intermediate circuit configuration. Skin air outlet valve is an electrically operated single flap valve with a smaller flap built into it. This outlet valve, there is a small flap is there. This small flap is open in flight or on ground with takeoff power is selected when the skin temperature is above. So this is the temperature configuration, will not go on the numerical value. Measure the range of skin temperature sensed is between minus 50 degree to 80 degrees Celsius. Outside of this range, AEVC set the avionics ventilation configuration to a intermediate configuration or partially open condition. So this is the temperature variation. So this configuration will automatically come into the picture. So you can see inlet valve is closed. Partial open means the small flap of the outlet skin air outlet valve will be open. So you can see air is going, cooling, then extractor fan, and it will vent it out. We will discuss in next slide in detail. You will better understanding. Rest all process is same like closed configuration. So just a small amount of air will blown out through the skin air outlet valve. So you can understand about the chart or temperature how it is working. So if you'll talk about blower fault or extractor fault alert you are getting, just for example, when the blower or extract push button switch is set at the override position, the system is in closed circuit configuration and adds air from the air conditioning system to the ventilation air. So this is very good to know information. If you are having blower fault or extractor fault alert, when the blower and extractor push buttons is set to override position, system is in will go to the closed configuration. You can see the you have selected, suppose just you have selected blower fan and extractor fan in override condition. Normally it will be in auto condition. What is happening? It will close this skin air inlet valve, it will close the skin air outlet valve, and here he will get this will get signal air conditioning inlet valve will open to provide the air for cooling of the avionics equipment ventilation system. Good to know, when the blower push button switch is set at override, blower fan is stopped and extractor fan continues to run, because some smoke is there that should be removed from the avionics bay. That's why if you are selecting the blower push button in override condition, blower fan will off, but extract fan will continuous to rotate. When the extractor push button switch is set to override, what is happening? Extract fan is controlled directly from the push button. Both fan run continuous. So during this condition, both fan will run continuously. So here if you see another example, I have talked about partially open. Suppose you are applying MEL procedure, deactivating outlet valve in closed configuration, then you have to open the small flap through whatever AMM is suggesting. This is because I am just sharing for knowledge. Suppose smoke configuration, when the smoke detector detected smoke in the avionics ventilation air, the blower and extractor fault light will come on if smoke detection is there. When the blower and extractor push button is set to override position, air conditioning system supply the cooling air and is exhausted over board through a small flap. So you can see the small flap is open and air conditioning, you are taking air from air conditioning and it will cool all the avionics equipment and it will blown out. So this is all about the avionics equipment ventilation system. Just keep in mind there is a 3 configuration: open circuit configuration, closed circuit configuration, and partially open circuit configuration. I have explained everything. And one more thing, during rain, suppose you are in the flight, our arrival captain will supposed to put a blower extractor fan in override condition. During this situation, both inlet and outlet valve will close, then computer will get hot. Make sure that pack is running continuously, because from pack only air conditioning inlet valve only gives supply for the avionics equipment ventilation cooling in closed circuit configuration. So pack must be run, at least one pack must be run to supply this for avionics equipment ventilation system. This is your critical system in avionics equipment ventilation system. So whenever you are going to apply MEL for skin air inlet valve or outlet valve, take proper precaution, take your time. And especially on outlet valve, once you are deactivating in closed condition, that small flap will be open. You should see the ECOM indication must be green in partially open. If it is wrong setting, then there may be chance of air turn back. So with this, almost I have covered everything in avionics equipment ventilation system. Regarding MEL, we'll discuss in separate chapter. And hope you love this video. And if you really love this video, don't forget to like, share, subscribe for getting more video on Airbus 320 family.